Welcome to What's a GPU Anyway? I'm Stephanie Kermer and I'm a senior data scientist at Saturn Cloud. We talk about GPUs a lot in the context of machine learning because of their potential to accelerate machine learning tasks tremendously. However, it's really important to understand what the difference is between a GPU and a CPU in order to determine whether it's actually the right choice for a particular machine learning task that you might want to do. In this explainer, I'm going to tell you a little bit about the inner workings of CPUs and GPUs, and then we'll talk about what makes a GPU useful for certain tasks, but not for others. Now, I'm not assuming that you have any familiarity with computer processors or CPUs or GPUs coming into this video, so let's talk a little bit about what we really mean. Computer processors are the hardware that allows computers to do mathematical calculations. And those mathematical calculations really power all of the computation and all of the electronic devices even that we use on a day-to-day basis. This goes everywhere from your cell phone to your laptop to a supercomputer. Everything comes down to processors, which really usually take the form of either CPUs or GPUs. Before we explain what the difference is between CPUs and GPUs under the hood, let's talk about cores and threads. A core is a piece of hardware in a computer, and it receives instructions to process a thread, which is a unit of work. Then the core will return the results of that work after the execution is complete. A core can really only do one thing at a time, but it can fake multitasking by switching back and forth between threads if necessary. Ideally, more cores means more work can be done at the same time, and this will be important later when we explain how GPUs work. Now let's take a look at the central processing unit, or CPU. As you can see on the left, the elements of the CPU core are relatively simple. A control unit, an arithmetic logic unit, which is the home to most of the calculations that are completed, and then the level 1 memory cache. In a CPU microprocessor, you may have multiple cores as shown on the right. And then you'll have an additional level 2 memory cache that is also available for the processes to use. Now, when we get into looking at the graphical processing unit, or GPU, you'll see that things get more complicated really quickly. GPUs were originally built to make graphics rendering on computer screens and video games faster and sharper. However, it was discovered that the same technology had the potential to make machine learning tasks faster too. There are a lot more moving parts inside of a GPU chip. This chip happens to be the Ampere chip from NVIDIA, although there are many other varieties of GPU, and they may not all look like this inside. The arithmetic logic unit is still represented in the core, but it really doesn't work the same way as it does in CPU, and there are a lot more pieces to be considered. There are many more cores, there are different kinds of cores, and the way that memory caches are handled is different, and all of this is held in an entirely different sort of architecture. It's also worth noting, in addition to being way more complicated than a CPU core, GPUs are not, in fact, always better at doing everything. GPUs are actually slower head-to-head than CPU cores. They have a harder time handling certain complex instructions. They have less access to memory caches, which can contribute to the slowness, and fewer libraries and frameworks in the programming languages you may be familiar with are actually able to run on a GPU core, partly because of the added complexity of the hardware. So why are we using GPUs for anything again? One major reason to use GPUs for machine learning and data science in particular is that there can be vastly more cores in a GPU than in a CPU. This means that you can do a lot more tasks in parallel on a GPU than you can in a CPU, even if the kinds of tasks that you can do are somewhat limited. Furthermore, as more libraries and more packages support GPU computation, more things will be possible to do on GPUs, and so the acceleration that's possible will be expanding as time moves on. Here's just a sample of the machine learning libraries that are currently available to support GPU computation, in the Python ecosystem in particular. These are just a few of the things that you can use to run your own machine learning computations on GPU hardware and take advantage of the speed opportunities that are available. Thanks for joining me for this video about GPUs for machine learning. If you'd like to learn more about this or use a GPU yourself for your own machine learning completely free, visit us at saturncloud.io.